Good morning, class. I hope you all had a wonderful weekend. I am so excited to start this new lesson with you. Our lesson is called Let's Warm Up, and this is a lesson on how sunlight warms the earth by me, Miss Winaski. So let's get started. This lesson is made for grade level second grade. So since you guys are all in second grade, this lesson will be perfect for you. We have two learning objectives that we will try to accomplish through this lesson. So the first one is students will be able to identify the sun as their heat source that warms the earth. And the second one is students will be able to predict and explain why a popsicle will melt faster in the sun versus the shade based on our class experiment. So before we get into any experiments, I want to see what you already know. So go ahead and take out your tablet now. We're going to do this together as a class and do it through Google Jamboard. All right, so let's pull that up and get that started. All right, so once again, our lesson is Sunlight Warms the Earth. And here, I want you guys to make some predictions. Why do you think the sun warms the earth? You may not know the reason, but I'm sure you have observed some things about the sun and maybe reasons why it does warm the earth. So go ahead and take a sticky note here, and then I want you to post it on the next slide here. And once all your sticky notes are in, we'll come back together as a class and read some of your predictions. I'm so excited to see what you guys write. All right, it looks like everyone has posted their sticky notes, so let's see some of your responses. All right, Ben said Earth is close to the sun, which is true. Brian said the sun feels warm. It does feel warm. Johnny said the sand is hot at the beach. It sure is, especially on a hot, hot day. Vivian says because it's hot. You're right, the sun is very hot. Chris said the pavement gets hot in the sun. Yes, just like the sand, it gets very hot, and to walk on bare feet, it hurts your feet. Julia says because I get sunburned when I stay in the sun for too long. Yeah, a lot of us do get sunburn. That's because the sun is so powerful. We'll learn more about that as we go through this lesson. Eva said sunny days feel warm. They do. Jack says because the sun is so bright, and it is very bright. Camille said it is hot outside when it is summer, and that is very true. And Chloe said daytime is warmer than night, which is true because that's when the sun is out. So excellent job there. All right, so let's continue learning. So we're going to watch a quick YouTube video that will explain a little bit about how the sunlight warms the earth, and then we'll come back and we'll discuss what we learned.
Yeah, sure. It's actually fine.
Pop quiz. What's the closest star to Earth? It's called Sol. Never heard of it, you say? Sure you have. Sol is the sun. Ancient Romans, who once worshipped the sun, called it Sol, and it's become the kind of official scientific name for the sun. It's where the term solar system comes from. Sol, or the sun, is the star at the center of our 8-planet solar system that provides us with energy. Without the sun, Earth would be a dark, frozen world with no life. But how does the sun's energy get to us? Well, first, let's talk about what the sun is. It's a 5 billion-year-old big ball of super hot gas. The hottest part of the sun is its core, or center, which is about 15 million degrees Celsius. Whoa. Its surface is not quite as hot, but it's still almost 5,600 degrees Celsius, which is pretty toasty if you ask me. And as for its size, the sun is so huge, you can line up over 100 Earths along the face of it, and more than 1 million Earths could fit inside it. But the sun's size isn't what makes it seem so big and bright to us on Earth. It's because it's so close to us that it seems way, 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 way bigger and brighter than other stars. So, you know that the sun is hot and bright, and that heat and light are both kinds of energy that we get from the sun. Let's take a look at a model to see how the sun's energy gets from good old Sol to our planet. Here's the sun. energy is created in its super hot 15 million degree core. That energy then travels outward from the core to the surface of the sun. But this journey from the center of the sun to its surface can take over 100,000 years to complete. But once the energy deep inside the sun finally gets to the surface, it travels as light and heat all the way to Earth. In fact, it only takes about 8 minutes for light to travel approximately 150 million kilometers through space to Earth over here. That's not such a long time. So to sum up, energy is created in the sun's core. It travels very slowly to the sun's surface before it takes a super speedy trip to Earth in the form of light and heat. And you and I can see and feel that energy as sunlight. Without the heat and light we get from the sun, Earth would be just a frozen ball floating around in space, which would be a total bummer. So, thanks, Soul. You're a real star.
All right, I hope you enjoyed that video and learned a few things. So the sun is the closest star to Earth, but what is a star? Let's think about that. Well, a star is a bright object that gives off light by the energy produced in its core. And we learned that in the video, that the energy of the sun is produced in the core of the sun. Without the sun, Earth would be a dark, frozen world with no life. The sun is a 500 billion year old ball of gas. And the sun is so big that 100 Earths can line up along the face of the sun, and more than 1 million Earths can fit inside of the sun. It's huge. Energy that comes from the sun. So there's two kinds. So the first one is heat. It's a kind of energy that warms things. And the second is light, and it's a kind of energy that illuminates things. And if you don't know what illuminate means, that means to like brighten things or have like a light on it. So, all right, and we see and feel heat and light energy through sunlight. All right, kids, get excited because it's time for an experiment. Now, do you think a popsicle will melt faster in the sun or in the shade? Think about that for a minute. So first, what is shade? So shade occurs when something, whether it's a tree, umbrella, building, or anything that obstructs the sun radiation from coming through. So if you were to look at this picture, can you see where the shade is in this picture? So let's see, it looks sunny, 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 but all this is shaded by the tree, and it's a dark area there, so the sunlight is not getting through to those dark areas. All right, so this is our experiment. I'm very excited. It's the popsicle experiment. So since there are 10 of you in our class, 5 of you will place their popsicles in the direct sunlight. The other 5 are going to find a shady spot out on the playground and place their popsicles there. Now you all have your science journals with you, so I want you to write down what your prediction will be. What will happen? Will the popsicles in the sun melt faster? Will the popsicles in the shade melt faster? Will they melt at the same time? And every 10 minutes as a class, we'll go outside and we'll observe our popsicles and write down our observations in our science journals. Let's get started.
Okay, we just started our experiment and the students chose a place that is direct sunlight to put their popsicles in and a place that is shady. So here, okay, we just started our experiment and the students chose a place that is direct sunlight to put their popsicles in and a place that is shady. So here are the students that chose direct sunlight, and then the other group went behind our class garden and found a spot that was very shady. So we just placed these popsicles down. So we're going to check back in 10 minutes and see what their observations are. Okay, class, it's been 10 minutes. Let's go check the popsicles and see if we have any results yet. All right, so the popsicles in the sun. What do you guys notice? Yeah, you're right. There hasn't been much melting going on. Let's go look at the ones in the shade. What do you guys notice? Yeah, you're right. It doesn't look like there's much melting going on, but they still look a little more frozen, as you can see the white on there. Well, today it's only 59 degrees out, and even though the sun is shining, there's a few clouds in the sky, so I wonder if that's affecting it. We'll check back in 10 more minutes. All right, class, it's been another 10 minutes. Let's go check on our popsicles. Okay, first we're going to check on the ones in the sun. Oh, look like we have some melting going on here. All right, let's go to the ones in the shade and see what's going on there. Oh, we could see that they're starting to melt, but there's definitely not as much melting as the ones in the sun. So I think you guys are right. The ones in the sun are going to melt faster. Let's check back in another 10 minutes and see. All right, it's been another 10 minutes, so we're going to check our popsicles. This is the last time we're going to check them, so let's see what we have. So first we're going to go to the ones in the sun. Oh, and they are almost completely melted. You could see the popsicle sticks and everything melted off of them. Okay, so those are melted, so let's go check out the ones in the shade now. Oh, we could see they're starting to melt, but they didn't nearly melt as fast as the ones in the sun. The popsicle is pretty much still on the stick. So it looks like you guys were right. The ones in the sun did melt faster than the ones in the shade. Great job, everyone.
All right, so that was a really fun experiment, wasn't it? Sorry you guys didn't get to eat the popsicles, but I hope you still had fun. Okay, so what did we learn from our experiment? Well, the reason that the popsicles melted faster in the sun is because sunny areas do not obstruct the sun's radiation from coming through. Therefore, it is much warmer because all of the sun's energy is being permitted. So all those popsicles that were just sitting in the bright sunlight were getting more radiation and therefore melted at a faster rate. All right, now it's time to check out what you learned. So just take a few minutes and answer some of the questions that I created on Kahoot for you. So let's open this up. All right, so go ahead and take your time. There is 8 questions there. The first one, what is the sun? The second one, the sun is the closest to the star to the earth, and that's a true or false. So just go through these and answer as best as you can. Remember what we learned from the video, what we learned from the slides, and what we learned from our experiment. All right, you guys all did an excellent job today, and I hope you really enjoyed this lesson.